Hello everybody, hope you're having a great day today. We are going to work on rationalizing the denominator some more, but today we're going to use conjugates to rationalize the denominator. So what is a conjugate? Well, they have a little description up here, a little definition. Basically what a conjugate is if you have a plus b. In other words, if you're looking at a minus b is the conjugate. So it's the opposite. Remember, we want when we have a plus b times a minus b, we had that a squared minus b squared thing happening. So that's basically what we're looking for again here. And the reason that we're going to do that is because if I have in the denominator an irrational number here, but it's attached to a rational number like this, and we have 2 minus this number, we have more than one term down here, it's kind of hard to rationalize it by just multiplying by one thing. So here it says simplify 7 over 2 minus the square root of 3. So we're going to use a conjugate to rationalize the denominator. So we're going to multiply both the top and bottom by the conjugate of 2 minus the square root of 3, which is 2 plus the square root of 3. Now we can't just multiply the denominator by that and not the numerator, so we're also going to multiply the numerator by 2 plus the square root of 3. So on the bottom, this is going to give us a squared minus b squared thing happening because it's a minus b times a plus b happening. So 2 squared would be 4. And then minus b squared, well, square root of 3 squared is 3 because if you square the square root sign, it cancels each other out. They're opposites of each other, right? They're inverse operations. So the square root of 3 squared would just be 3, so it would be 4 minus 3. And on top, I'd have 7 times 2 plus square root of 3. So, you're going to distribute this to both things. 7 times 2 is 14. And then we have 7 times the square root of 3, positive square root of 3, which is positive 7 square root of 3. You can't multiply things that are outside the radical and inside. So it's not going to become the square root of 21 because 7 is not inside of a radical sign. So it's like you multiply this 7 times the 1 that's in front of this square root of 3. So 7 times 1 is 7, so 7 root 3. So we'll simplify the bottom here, which 4 minus 3 is 1. So we'll have 14 plus 7 root 3. Now if in the denominator there was a number like 7 or something, then we would simplify this 14 and we would simplify the 7. But since there's a 1 underneath, we just leave it on how it is. Alright, so now we've simplified it. We can't combine these at all. They're not like terms, so we can't combine it. And that's what we have. Alright, so if you are ready, why don't you try these 3 out here. We'll try these 3 out. Simplify the expressions by using the conjugate to rationalize the denominator. So pause your screen, try them out, and then when you're ready, press play, and we'll see if we have the same answers. Okay, so for this one here, I'm going to multiply the top and the bottom by the conjugate of 1 plus the square root of 3, which is 1 minus the square root of 3. Alright, on the bottom, that becomes a squared minus b squared. So I'm going to get on the denominator 1 minus 3. And in the numerator, 8 times 1 is 8 minus 8 root 3. So now I have 8 minus 8 root 3 over negative 2. Now if we look at this, can this be simplified any further? Well, we're looking at the numbers in front here, right? 8 and negative 2 and negative 8 and negative 2 all can have negative 2 go into them, right? So we're going to simplify this. This becomes negative 4, because 8 divided by negative 2 is negative 4, and negative 8 divided by negative 2 is positive 4. So it turns into negative 4 plus 4 root 3 over 1, but we don't have to write that. So that is our answer for the first example. For the second example, we're going to multiply both the top and the bottom by the square root of 5 plus 2. Alright, and so on the bottom, it's going to become a squared minus b squared, so square root of 5 squared is 5. 2 squared is 4, so 5 minus 4 on the bottom. The top, the square root of 13 times the square root of 5 would be the square root of 65. And the square root of 13 times 2 would be 2 square root of 13. Now my denominator becomes 1. Look at the square root of 65. Are there any perfect squares that go into 65? No. So square root of 65 plus 2 root 13 is going to be my answer to this one. It's over 1, but we don't have to write that. And for this one here, the conjugate of the square root of 2 plus the square root of 7 would be the square root of 2 minus the square root of 7. So we'll multiply the top and bottom by that. So the top becomes 12 root 2 minus 12 root 7. And the bottom becomes 2 minus 7, which is negative 5. We don't want to have the negative in the denominator. If you remember from a different lesson, we never want to have negative sign in the denominator. So the negative can go in front of the whole fraction, or you can change the whole numerator and change the sign. So instead of this being positive 12 square root of 2, it would be negative 12 root 2 plus 12 root 7 over 5. That's just because it's not proper to have a negative sign in the denominator. So that would be our answer. All right, so these are the answers for these three. If you have any questions, please write them down on the questions doc or come hang out during the Open Google Meet and ask some questions on it. Try out the BIM. If there's any questions on that, again, join the Open Meet and we can talk about it. I'll walk you through it. If you put the question on the Google Doc, I'll try to provide a video for you through that way. But good luck on this. Again, if you have any questions, please let me know.